Article 700 of the National Electrical Code, or NEC, addresses emergency systems. Specifically, the question of whether normal power feeds to transfer switches must be installed ahead of the service disconnecting means is addressed. The answer is yes. Let's delve into why this is the case and what the implications are for electrical installations. Emergency systems are designed to provide power to critical loads during a failure of the normal power supply. These systems are essential for life safety, fire protection, and other critical functions in buildings and facilities. Transfer switches are a key component of emergency systems as they automatically switch the load from the normal power source to the emergency power source, such as a generator, when a power outage occurs. The requirement that normal power feeds to transfer switches be installed ahead of the service disconnecting means is intended to ensure that the emergency system can operate independently of the normal power system. If the normal power feed to the transfer switch were installed after the service disconnecting means, then a failure or shutdown of the normal power system could also disable the emergency system. To understand this better, let's consider a typical electrical distribution system in a building. The service disconnecting means is the main switch or circuit breaker that disconnects the entire building from the utility power supply. This is usually located near where the power enters the building. Downstream of the service disconnecting means are distribution panels that feed power to various loads throughout the building. If the transfer switch were fed from a distribution panel downstream of the service disconnecting means, then if the service disconnecting means were opened, either intentionally or due to a fault, the transfer switch would lose its normal power feed and would be unable to switch to the emergency power source. This would defeat the purpose of having an emergency system in the first place. By installing the normal power feed to the transfer switch ahead of the service disconnecting means, the transfer switch is assured of having a reliable normal power source, regardless of the status of the service disconnecting means. This ensures that the emergency system can function as intended in the event of a power outage. There are some exceptions and specific requirements that apply to this general rule. Firstly, the specific requirements for emergency systems can vary depending on the occupancy and application. For example, hospitals, data centers, and other critical facilities may have more stringent requirements than office buildings or retail stores. Secondly, the NEC allows for alternative arrangements in some cases, as long as the emergency system is designed to provide the required level of reliability and performance. Thirdly, it is essential to consult with a qualified electrical engineer or contractor to ensure that the emergency system is designed and installed in accordance with all applicable codes and standards. Let's consider some specific examples of how this requirement applies in different situations. In a hospital, emergency power is critical for maintaining life support systems, operating rooms, and other essential medical equipment. The transfer switches that feed these loads must be installed with normal power feeds ahead of the service disconnecting means to ensure that they can switch to emergency power immediately in the event of a power outage. In a data center, emergency power is essential for preventing data loss and maintaining business continuity. The transfer switches that feed the servers, network equipment, and cooling systems must be installed with normal power feeds ahead of the service disconnecting means to ensure that the data center can continue to operate even if the utility power fails. In a high-rise office building, emergency power is needed to power the fire pumps, elevators, and emergency lighting systems. The transfer switches that feed these loads must be installed with normal power feeds ahead of the service disconnecting means to ensure that occupants can safely evacuate the building in the event of a fire or other emergency. The NEC provides detailed requirements for the design, installation, and testing of emergency systems. These requirements cover a wide range of topics, including the sizing of generators, the selection of transfer switches, the wiring methods, and the grounding and bonding requirements. It is essential to carefully review and comply with all applicable NEC requirements when designing and installing an emergency system. One important consideration is the coordination of overcurrent protective devices. The overcurrent protective devices in the emergency system must be coordinated with the overcurrent protective devices in the normal power system to ensure that a fault in one system does not trip the overcurrent protective devices in the other system. This coordination is essential for maintaining the reliability and availability of both the normal and emergency power systems. Another important consideration is the testing and maintenance of the emergency system. The NEC requires that emergency systems be tested regularly to ensure that they are functioning properly. These tests should include testing the operation of the transfer switches, the performance of the generator, and the condition of the batteries. Regular maintenance is also essential for ensuring the long-term reliability of the emergency system. This maintenance should include inspecting and cleaning the equipment, lubricating moving parts, and replacing worn or damaged components. The placement of the transfer switch ahead of the service disconnect has implications for the overall design and operation of the electrical system. Firstly, it means that the transfer switch and its associated wiring must be sized to handle the full load of the emergency system. Secondly, it means that the transfer switch must be located in a readily accessible location so that it can be inspected and maintained. Thirdly, it means that the transfer switch must be protected from physical damage and environmental conditions. There are several different types of transfer switches available, including automatic transfer switches, manual transfer switches, and bypass isolation transfer switches. Automatic transfer switches automatically switch the load from the normal power source to the emergency power source when a power outage occurs. Manual transfer switches require manual operation to switch the load from one source to the other. Bypass isolation transfer switches allow the transfer switch to be bypassed and isolated for maintenance or repair without interrupting power to the load. The selection of the appropriate type of transfer switch depends on the specific application and the level of reliability required. Automatic transfer switches are typically used in critical applications where an interruption of power is unacceptable. Manual transfer switches are typically used in less critical applications where a brief interruption of power is acceptable. Bypass isolation transfer switches are typically used in applications where it is essential to be able to maintain or repair the transfer switch without interrupting power to the load. In addition to the NEC, there may be other applicable codes and standards that govern the design and installation of emergency systems. For example, the National Fire Protection Association, or NFPA, publishes standards that address emergency power systems in healthcare facilities, data centers, and other types of buildings. It is essential to consult with the local authorities having jurisdiction to determine which codes and standards apply to a specific project. The installation of the normal power feed to the transfer switch ahead of the service disconnecting means is a critical safety requirement. It ensures that the emergency system can function properly in the event of a power outage. Failure to comply with this requirement can have serious consequences, including loss of life, property damage, and business interruption. It is important to note that the requirements for emergency systems are constantly evolving as new technologies and applications emerge. It is therefore essential to stay up to date on the latest codes and standards and to consult with qualified professionals to ensure that emergency systems are designed and installed in accordance with best practices. The specific location of the tap for the emergency system ahead of the service disconnecting means is also important. Firstly, the tap must be made in a manner that complies with the NEC requirements for service conductors. Secondly, the tap must be protected from physical damage. Thirdly, the tap must be readily accessible for inspection and maintenance. One common method for making the tap is to use a service entrance rated junction box. The service conductors are run into the junction box, and the tap for the emergency system is made inside the junction box. The junction box must be properly grounded and bonded, and the conductors must be properly sized and protected by overcurrent protective devices. Another method for making the tap is to use a tap box or a similar device that is specifically designed for making service taps. These devices typically include features such as built-in overcurrent protection and easy access for inspection and maintenance. Regardless of the method used, it is essential to follow all applicable NEC requirements and to consult with a qualified electrical engineer or contractor to ensure that the tap is made safely and correctly. The normal power feed to the transfer switch should also be monitored for voltage and frequency. This monitoring can be used to detect power outages and other abnormal conditions that may require the transfer switch to switch to the emergency power source. A monitoring system should be designed to provide reliable and accurate information to the transfer switch so that it can make the correct decision. In some cases, it may be necessary to provide a separate overcurrent protective device for the normal power feed to the transfer switch. This overcurrent protective device should be sized to protect the conductors and equipment in the emergency system, and it should be coordinated with the other overcurrent protective devices in the electrical system. The installation of the normal power feed to the transfer switch ahead of the service disconnecting means is a complex and critical task. It requires a thorough understanding of the NEC requirements as well as the specific requirements of the application. It is therefore essential to hire a qualified electrical contractor with experience in designing and installing emergency systems. It is also important to document the installation of the emergency system, including the location of the tap for the normal power feed, the size and type of conductors used, and the settings of the overcurrent protective devices. This documentation will be helpful for future maintenance and troubleshooting. The normal power feed to the transfer switch is a critical component of the emergency power system and it is not to be neglected. It must be installed in accordance with all applicable codes and standards to ensure that the emergency system can function properly in the event of a power outage.